Even a weekend getaway to space can alter astronauts' biology, a sweeping new study finds. Even 3 days in space is enough to alter an astronaut's biology, according to a new set of studies that offers the most comprehensive look at space flight health since NASA's Twins study. Only about 600 people have ever traveled to space. The vast majority of astronauts over the past 6 decades have been middle-aged men on short-duration missions of fewer than 20 days. Today, with private, commercial, and multinational spaceflight providers and flyers entering the market, we're witnessing a new era of human spaceflight. Missions have ranged from minutes, hours, and days to months. As humanity looks ahead to returning to the moon over the coming decades, space exploration missions will be much longer, with many more space travelers and even space tourists. And this also means that a wider diversity of people will experience the extreme environment of space, more women and people of different ethnicities, ages, and health status. Since people respond differently to the unique stressors and exposures of space, researchers in space health, like me, says the writer, seek to better understand the human health effects on spaceflight, and with such information we figure out how to help astronauts stay healthy both while they're in space and once they return to Earth. As part of the historic NASA Twin study in 2019, my colleagues and I published groundbreaking research on how 1 year on board the International Space Station affects the human body. I'm a radiation cancer biologist in Colorado State University's Department of Environment and Radiological Health Sciences. I spent the past few years continuing to build on that earlier research in a series of papers recently published across a portfolio of Nature journals. These papers are part of Space Omics and Medical Atlas package of manuscripts, data, protocols, and repositories that represent the largest collection ever assembled for aerospace medicine and space biology. Over 100 institutions from 25 countries contributed to the coordinated release of a wide range of spaceflight data. The NASA's Twin Study seized on a unique research opportunity. NASA selected astronaut Scott Kelly for the agency's first 1 year mission, during which he spent a year on board the International Space Station from 2015 to 16, and over the same time period his identical twin brother Mark Kelly, a former astronaut and current U.S. Senator representing Arizona, remained on Earth. My team and I, the writer said, examined blood samples collected from the twin in space and his genetically matched twin back on Earth before, during, and after spaceflight. We found that Scott's telomeres, the protective caps at the end of chromosomes, much like the plastic tip that keeps the shoelace from fraying, lengthened quite unexpectedly during his year in space. When Scott returned to Earth, however, his telomeres quickly shortened. Over the following months, his telomeres recovered, but were still shorter after his journey than when they had been before he went to space. As you get older, your telomeres shorten because of a variety of factors, including stress. The length of your telomeres can serve as a biological indicator of your risk for developing age-related conditions such as dementia, cardiovascular disease, and cancer. In a separate study, my team studied a cohort of 10 astronauts on 6-month missions on board the International Space Station. We also had a control group of age and sex-matched participants who stayed on the ground. We measured telomere length before, during, and after spaceflight, and again found that telomeres were longer during spaceflight and then shortened upon return to Earth. Overall, the astronauts had many more short telomeres after spaceflight than they had before. One of the other twin studies, investigators Christopher Mason and I conducted another telomere study, this time with twin high-altitude mountain climbers, a somewhat similar extreme environment on Earth. We found that while climbing Mount Everest, the climbers' telomeres were longer, and after they descended, their telomeres shortened. Their twins who remained at low altitude did not experience the same changes in telomere length. These results indicate that it's not the space station's microgravity that lead to the telomere length changes we observed in the astronauts. Other culprits, such as increased radiation exposure, are more likely. Civilians in space. In our latest study, we studied telomeres from the crew onboard SpaceX 2021 Inspiration 4 mission. This mission had the first all-civilian crew whose ages spanned 4 decades. All of the crew members' telomeres lengthened during the mission, and 3 of the 4 astronauts also exhibited telomere shortening once they were back on Earth. And what's particularly interesting about these findings is that the Inspiration 4 mission lasted only 3 days. So not only do scientists now have consistent reproducible data on telomeres response to spaceflight, but we also know it happens quickly. These results suggest that even short trips like a weekend getaway to space will be associated with changes in telomere length. Scientists still don't totally understand the health impacts of such changes in telomere length. We'll need more research to figure out how both long and short telomeres might affect an astronaut's long-term health. Telomeric RNA. In another paper, we showed that the Inspiration 4 crew, as well as Scott Kelly and high-altitude mountain climbers, exhibited increased levels of telomeric RNA, termed TERA. Telomeres consist of lots of repetitive DNA sequences, and these are transcribed into TERA, which contributes to telomere structure and helps them do their job. Together with laboratory studies, these findings tell us that telomeres are being damaged during spaceflight. While there's still a lot we don't know, we do know that telomeres are especially sensitive to oxidative stress. So the chronic oxidative damage that astronauts experience when exposed to space radiation around the clock likely contributes to the telomeric responses we observe. We also wrote a review article with a more futuristic perspective of how better understanding telomeres and aging might begin to inform the ability of humans to not only survive long-duration space travel, but also to thrive and even colonize their other planets. Doing so would require humans to reproduce in space and future generations to grow up in space. We don't know if that's even possible yet. Plant telomeres in space? My colleagues and I contributed other work on the space, omics, and medical atlas package as well, including a paper published in Nature Communications. The study team led by Texas A&M biologist Dorothy Shippen and Ohio University biologist Sarah Wyatt found that unlike people, plants flow in space did not have longer telomeres during their time on board the International Space Station. The plants did, however, ramp up the reproduction of telomerase, the enzyme that helps maintain telomere length. As anyone who sees The Martian knows, plants will play an essential role in long-term human survival in space. This finding suggests that plants are perhaps more naturally suited to withstand the stressors of space than humans. The article was published from the conversation under Creative Commons here by Susan Bailey, professor of Radiation Cancer Biology and Oncology, Colorado State University, and this is on Live Science. Please leave your comments and thank you for your support. Finally, support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.